Hello, everyone. Good morning. Can I start? Okay. Good morning, everyone. Welcome to our Data Science and Economics program talk. My name is Chun. I'm from NUS Department of Mathematics. Today, myself, together with Dennis from Department of Economics, also in NUS, we will be covering the program talk of DSE. And with us, we also have Prof. Victor Tan, who is the program director from Department of Mathematics. So I will begin with an overview of the digital landscape and discuss how DSE, Data Science and Economics Interdisciplinary Program, will fit into it. Then after me, Dennis will take over to share more about the economics perspective. After that, we will host the Q&A session. Without further ado, let us begin. Economics today is no longer confined to textbooks and theoretical models. It has been reshaped and is being reshaped by digital transformation, big data, and artificial intelligence. Our DSE program is built around this new reality. It integrates data science with economics, equipping students with the analytical, computational, and economic reasoning skills needed to solve complex real-world problems. We are living in the fourth industrial revolution. Industries today require professionals who can understand economic mechanism, work with large-scale data, build predictive models, and to support policy and business decisions. Our DSE is designed to meet these demands. Students will learn how to synthesize knowledge across disciplines and apply it in dynamic sectors like the finance, the technology, and public policy. Our program is jointly offered by Department of Mathematics, Department of Statistics and Data Science under Faculty of Science, as well as Department of Economics under Faculty of Arts and Social Sciences. We are all under the College of Humanities and Sciences, which is abbreviated as CHS. Our students will be equipped with strong foundational knowledge in data science and economics, as well as practical experience in the empirical analysis of economic and financial data. Our cross-disciplinary program in data science and economics will produce graduates who can make effective policy and business decisions anchored on data-driven innovation. So our curriculum is carefully designed. We integrate data science and economics seamlessly. We do not simply put them side by side. Otherwise, it's offered as an integration. We specially design the cross-disciplinary courses on emerging products and technologies such as digital currencies and fintech, as well as to address and tackle the challenging problems in digital economy. To say why our program is really something you want, then maybe let me start with a journey to guide you through the three important pillars in the digital world, namely the digital economy, the fintech, as well as digital currency. Okay, let's start with digital economy. The TechCrunch noted that Uber, which is the world's largest taxi company, owns no vehicles. Facebook, which is world's most popular media owner, creates no content. Alibaba, which is the world's most valuable retailer, has no inventory. And Airbnb, which is the world's largest accommodation provider, owns no real estate. So from these examples, you see something interesting is happening around us. The World Economic Forum defines the digital economy as economic activities that include the usage of digitized information and technology as the key factor of production, modern information networks as an important activity space, and the effective use of information and communication technology, which is ICT, as an important driver of productivity growth and economic structure optimization. So let us zoom into Singapore's landscape. So based on Singapore's digital economy report in the 2025, which is last year, it shows that 1 year ago, which is in 2024, the nominal value added of Singapore's digital economy had reached more than 128.1 billion Singapore dollars. This was accounting for 18.6% of the national GDP. This has been raised even up from the previous year's 18% in 2023. So according to this figure, it shows that Singapore's digital economy now accounts for more than 1/6 of the national GDP. It means for every $6 Singapore, for every $6 dollar GDP, okay, more than $1 comes from digital economy. If we look at how fast the digital economy sector has grown over the past several years, okay, it shows that between the year 2019 to the year 2024, the value added of the digital economy grew, which was at a compound annual rate of actually more than 12%. This is significantly faster or higher than the growth rate of the nominal GDP, which was about 7.3% only. So if we zoom into the landscape of digital economy, clearly you can say the I&C sector, which is the information and communication sector, is the dominant leader within the digital economy landscape. So an I&C sector is the key driver, and it can be segmented into different industries, including software, IT services, hosting service, online service, IT consultants, e-commerce, telecommunication service, games, publishing, broadcasting, film, and videos, as well as museum. So big local companies like Grab, Shopee, and Garena are all the industry leaders within the I&C sector. So behind digital economy stands data science. Okay, if we look at the most important applications of data science in the digital economy landscape, we can say data science can help drive business decisions. For example, companies can use data analytics for smarter strategies. If you open your shop app like the Lazada or Shopee, then basically the app can give you different recommendations based on your personalized searching history in before. Okay, this of course is based on the data analytics. Besides it, we also have the power, the AI and automation. So for example, machine learning can help enhance personalization and efficiency. Okay, you can think about your experience chatting with the DBS AI-powered chatbots. Okay, and also we have optimization of operations. So, for example, data-driven, based on data-driven analytics, we can easily detect fraud, and we can do better forecasting. Okay, so one example in this field is the Grab's dynamic pricing and logistic optimization. Okay, last but not least, we also have enhanced customer experience. Nowadays, if you go to Changi Airport, then if you want to check in, normally it's the you can do it automatically, which means you just chat with the AI chatbots, and then basically you finish all of the necessary procedures you need for the check-in procedure. You don't need to communicate with human beings anymore. Okay, so after data science, let us come to fintech. Okay, Financial Stability Board defines fintech as technology-enabled innovation in financial services associated with new business models, applications, processes, or products, all of which have a material effect. So the technologies of our time or of our age that can be applied to the financial industry, including AI and machine learning, blockchain, natural language processing, open API, biometrics, chatbots, cloud, and as well as robotic process automation. Let us maybe use one case study in the digital payment industry to understand why data science is playing a key role for the industry leaders' business success. Okay, here I list the big ones within the digital payment industry. We have PayPal. We have, for example, we have PayPal here. We have Alipay here. We have our Google Pay and Apple Pay as well as WeChat Pay. Okay, so within these big ones, Alipay is the dominant industry leaders. So up to now, Alipay is the world's largest mobile or digital payment platform, which serves over 1.3 billion users and more than 80 million merchants, with more than 100 million transactions being processed daily. Okay, you can say Alipay actually is very successful nowadays. And then what makes Alipay so successful? One of the reasons is because Alipay successfully bridged with Alibaba's e-commerce platforms, which means Taobao and Tmall. So from Taobao and Tmall, the user data can be collected. Okay, I mean the user data for the daily transactions in Taobao and Tmall. So then Alipay analyzes this data to launch new offerings through its financial service arm, which is Ant Group. Within this, there is a credit rating system for merchants and customers. Okay, that is called JIMA. Okay, the rating system allows Ant Group to issue short-term customer and merchant loans with very low default rates. And with this rates, customers can purchase more from the e-commerce marketplaces, and the sellers can build up more inventory. This process mutually reinforces one another's market position. And this is one of the reasons, not the whole reason, but it is one of the reasons that support Alipay's success. Okay, so then after we talk about this case study, then easily we can say it's because Alipay can collect the user data and do the analysis based on it. This help boost the success of itself. Okay, then beyond it, let us look at the application of data science in the fintech industry at a broader perspective. Then firstly, data science can help design push market strategy, and also to help personalize help with chatbots, to help detect fraud and to improve security, as well as analyze customer behavior, forecast future market trend, design new product, as well as analyze customers' service results. Okay, then so again, you can say behind the technology, behind the fancy successful industry success stories, so it stands data science as well. Last but not least, let us also look at digital currency. Digital currency, firstly, it refers to money that exists exclusively in digital or electronic form. It remains entirely digital throughout its life cycle. These currencies are managed, stored, and exchanged through digital computer system. Transactions involving digital currencies are conducted via computers or electronic wallets connected to the internet or other specific networks. So here I give, up to now, okay, there are different generations of digital currency evolution. So roughly, okay, now we are at around the 5th generation of digital currency. So for the first generation, it was started by Bitcoin, and the second generation was empowered by the smart contract comes from Ethereum. And for the third generation, with Ethereum further polish its distributed consensus and introduce the so-called proof of stake. And the fourth generation is basically about the decentralized finance as well as the so-called Web3 economics. And as for the 5th generation, we are more talking about the stable coins and central bank digital currencies. Okay, so this is not a very strict chronological order. It is just that at different generations, we have different major innovations and people emphasize on different dimensions within this digital currency world. Okay. Then, so firstly, under digital currency, the most important, or maybe the most attractive examples comes from cryptography. Cryptography refers to digital or virtual currency that uses this should be cryptocurrency. Okay, cryptocurrency means a digital or virtual currency that uses cryptography for security and operates on decentralized networks based on blockchain technology. The leaders of cryptocurrencies, of course, we have the Bitcoin and Ether. Based on this Friday's data, okay, when this is the day when I finalize my slides, okay, you can see Bitcoin's market value, okay, is about one Bitcoin worth more than 80,000 Singapore dollars. And if you look at Ether, okay, one Ether nowadays is worth more than 2,000 Singapore dollars. Okay, wow, these are so expensive ones, and the reason why they are so expensive is because the demand is there. Without demand, the cryptocurrency basically worth nothing. Okay, and on the other hand, if you say some cryptocurrency has very high market value, it must means a lot of people trust in them and a lot of people demand them. Okay, then so if we look at if we take one step back to look at the entire cryptocurrency market, you'll see although the value of Bitcoin and Ethereum has been really high and significant, but their market domination actually decreases along the years. Okay, what does it mean? So this simply means although the market capitalization of Bitcoin and Ether, okay, each of them, the market capitalization has skyrocketed, but their market dominance has in total declined. This basically suggests besides these two market leaders, we have the entire market has exploded with a significant growth in alternative digital assets as well. Okay, here is a brief summary of the number of cryptocurrencies calculated at different years. You see, since the year 2013, the total number of cryptocurrencies exist in the market. Sorry about this. What happened? Okay, the total number of cryptocurrencies existing in the market have increased significantly, and the speed of increasing has also been increased. Okay, so according to this source comes from the CoinGecko. Okay, according to CoinGecko, the total crypto market capitalization nowadays has already reaches around 3.25 trillion US dollars. Okay, so although it is still slightly small compared to other major asset markets, but it already becomes comparable. Okay, here is the comparison between crypto market as well as other major asset markets in the world. You see, although this one is still slightly small, but it is already comparable to the other markets. Okay, so within cryptocurrency, one very outstanding category is stablecoin. Okay, stablecoin is also a type of crypto asset, or actually it also belongs to the cryptocurrency class. But this is so special because they aim to maintain a stable value by referencing an asset or a pool of assets. Nowadays, most of the stablecoins, like the USDT, USDC, and DAI, their reference point are basically the US dollars. Okay, in 2025, the total transaction volume of stablecoins, total transaction volume comes from the aggregate online data. This, by calculation, was over 40 trillion US dollars, with more than 39 billion US dollars in the real world payment. Okay, so these figures means the total on-chain transactions has already exist 40 trillion. While if we look at the real world payment of the stablecoin, okay, the total transaction volume was significantly smaller. It is about 39 billion. Okay, but anyway, if you compare the total transaction volume of stablecoin to the big payment companies like the Visa, MasterCard, and PayPal, okay, you see the total transaction volume by Visa, MasterCard, and PayPal accordingly are 14.5 trillion, 9.2 trillion, and 0.9 trillion respectively. This means for the total transaction volume wise, stablecoins our total transaction volume has already bypassed or exceeded the total transaction volumes of the world leading payment or traditional payment companies. And if we zoom into stablecoins real world usage, okay, you see, so it comes from mainly the B2B payments, the payroll and remittances, capital market settlement, and as well as some other real payments. Okay, nowadays for stablecoins, it has been widely used across all over the world. If you look at some developing countries, within which the national currency does not, basically the inflation rate is very high, the national currency cannot maintain a stable value, like Argentina. Okay, then in that country, the stable coin, okay, like USDT, has already been widely adapted by the normal people there. Okay, so after the stable coins, okay, very briefly, let's also look at the central bank digital currency, the CBDC. Okay, central bank digital currency refers to the digital version of the fiat currency that the central bank issues and maintains. There are two broad categories of CBDC. One is retail CBDC that is designed for public use. One is the wholesale CBDC that is designed for financial institutions usage. In Singapore, by now we don't have retail CBDC yet, but okay, so the MAS has already takes very early initiative in the wholesale CBDC. Okay, if you heard about the project Ubin, okay, this was the first project MAS involved in to experiment the usage of CBDC. It targets on the tokenized interbank settlement within Singapore. And by now, the project Ubin has already been completed. Okay, besides Ubin, our MAS also participated in project Damba. Okay, this is not so this is not a single country program. It is actually a collaboration of a lot of different nations, and Singapore is one of these. And the target of project Damba is to experiment of the application of wholesale CBDC for cross-border payments. Okay, after this introduction, okay, if we look at the digital currencies the development in Singapore, you see, okay, we have quite different step. I mean, the MAS, okay, actually has different of footprints, okay, in this development of digital currency. Okay, as I said, for example, in the year 2016, okay, MAS initiated Project Ubin. Okay, and in the year 2021, okay, so from the year 2021 onwards, MAS participated in Project Damba. Okay, and besides this, okay, we also have other development footsteps. Okay, so you can see as I show in this slide. Okay, after we have this discussion, okay, again, so data science plays a significant role in the industry of digital currency. It helps with the price prediction and market analysis. It helps analyze blockchain and to detect fraud, as well as to help with the smart contract risk assessment and so on and so forth. So after we have the journey in the three important pillars, digital economy, fintech, and digital currency, let's come back to our program. Okay, so our program structure can be split into three pillars. Firstly, we have the common curriculum courses, and most importantly, we have the major requirements. And besides that, the students also have some freedom comes from the unrestricted electives. So the focus for the program, of course, comes from the major requirement. You can say, so our program will prepare students to build strong foundations in mathematics, statistics, data analytics, economics, computer science, as well as the specially designed cross-disciplinary programs. Cross-disciplinary courses. Okay. So beyond the classroom learning, we also offer exponential learning opportunities for our students. Okay, so students can take internship, the full-time internship within a semester or during the summer vacations. They can also choose to participate in the overseas student exchange program. Okay, so then after talking so much, you may wonder, so where our graduate goes to work after they graduate. Okay, so fortunately, we already have the first batch of graduates that graduated in last year. According to our survey, okay, then our students has been placed to they all secure very good positions. Some of them go to the public sectors like MAS, okay, MOM, okay, or MOS. Okay, and some students go to the top investment bankings like Goldman Sachs. Some of them go to the world leading payment companies like MasterCard. Some of them go to local banks like DBS and OCBC. And some of them choose to go to big tech companies like ByteDance, TikTok, okay, and so on and so forth. Okay, you'll see from the last year's figure, our graduate placement are actually quite good, and we are very proud of them. Okay, okay. If you after this talk, if you think, yeah, maybe this will be the program I should consider, then how to apply it? Here comes the website. Okay, and then so very roughly. Okay, if you want to apply to this program, okay, according to past years data, the IGP, the indicative grade profile, is listed as below. Okay, so then here is some brief information about this program. But okay, this is not the end of the talk yet. Now I will hand over the time to Dennis, who will go through more about the economic perspective of the program. Now after that, if you have any questions, we will be happy to take it. Okay, Dennis, please.
Can you see my slides? Yes. All right.
Yes.
So again, very welcome from the DSC team, and thanks for coming to learn more about data science and economics today. So I'm going to talk from the perspective of economics, right? Because students have a very particular impression of economics from their JC curriculum, and this is just to show that things are quite different in reality, right? Economics has gone a long way from being this kind of essay-based, discourse-based science, right? The sort of the man of ideas who just talks, or maybe we should do this or that. This time is gone, right? And economics is actually quite a technical discipline, right? In particular, there is this subfield of economics which is called econometrics, which uses data to provide quantitative answers to economic questions. And this particular process, right, faces unique challenges in the context of economics because very frequently we need to estimate things like causal effects of certain policies, right, and decisions from what's called observational data, right? So we observe what happened, but we cannot always do experiments, right? So econometrics have devised many clever tricks to overcome this problem. And the methods from the domain of data science, machine learning, or AI skills, as they are now known, right? But they're essentially the same stuff, right? Having growing in importance in both academic economic studies and also in their applications in industry. So in some sense, data science provides new tricks for economists to do what they have been doing better and also try new type of analysis. Right. So what is exactly, data science in this context? Why data science and economics nexus makes sense? Well, you ask anyone, they will tell you that it's difficult to give a universal definition what exactly constitutes data science, right? But many would agree that it's a chair with, roughly speaking, three legs, right? There is the statistics and mathematical background, There is the execution of all these algorithms, right, which comes from computing. And then finally, the missing piece, right, has to be the context, has to be the domain where the techniques are being applied. And for the DSE major, right, that domain would be economics. So, if you talk to some of the recent Nobel laureates in economics, right? This is Joshua Angrist, who won his Nobel Prize for empirical work, right? Namely, discovering causal effects from the data. He would say that, econometrics is the original data science, right? Because it sort of combined the tight integration of cutting-edge statistical techniques and the intricate knowledge of the field of study, which is economics, right? So the types of questions economists tackle is usually broadly classified into two, right? The first one is non-causal prediction, right? How much money will our customers spend on our e-platform, for example, in the next month, right? That's just a question about how much money, right? But we don't ask what will cause our customer to spend that money, right? So it's just we trying to estimate revenue. Whereas the causal prediction, right, is a question that tries to ask, if we do something, right, if we intervene and, for example, give the customer a voucher, right, or give them some kind of incentive, what is the most accurate guess, right, for the change in the revenue that will result from this policy or program, right? So this type of questions are different, right, and they require different approaches. Right. So in economics, this kind of non-causal predictions could be, what is the inflation rate next year? What is the GDP growth next quarter? Will the customer buy a product or not? Will Singapore enter recession next year? Will the stock market or the cryptocurrency market go up or down next month? Right. Something like that. So you see that we are just trying to predict or forecast a particular value or particular event without really trying to claim, what causes that value to be taken or that event to happen, right? And we started answering this as early as the first class in the program, DSE 1101, Introductory Data Science for Economics. And one of the real data sets, right, that students get to analyze is this data on commercial vessel resale values. As you know, the maritime economy is quite prominent in Singapore. Right, so we built simple models to try to estimate the resale value of a used boat, right, based on some data. Recently, there has been a lot of unrest in the Red Sea and tankers and bulkers getting sunk and damaged. So, for example, from the point of view of insurance companies, right, or even naval operators, right, it's important to kind of get the estimate of the damage accurate. And so this is just an example of one of the models we built, right? It's called a decision tree. It's one of the basic machine learning algorithms. And if we apply to this data, we will basically see that, the size of the boat in terms of deadweight tons and its age at the time of sale, they are very important variables, right? So we can segment the prices in those two dimensions. And as a kind of a interesting check, we make a prediction for this bulker that I put in the news story here, right? That was sunk in 2024. And the tree that we built in class, right? Values it at $26 million, right? And its original building cost was actually $27 million, right? And it was sunk at being 2 years old. So this is a quite close estimate from even a very simple model, right? Of course, we go much more complex in subsequent years. Right. In terms of causal questions, this could be something like, how much does taxing cigarette actually reduce smoking, right? In terms of consumption of cigarette, what is going to be the effect of a $3 voucher, right, that Shopee gives you or Lazada gives you on sales revenue, right? What is the benefit of paying for being at the top of the Google search, right? Or these days probably pay to be mentioned by Google Gemini AI assistant, right? Or what is the difference in probability of being rejected for a mortgage based on, for example, race, right? Keeping other characteristic constant, right? So these are all causal questions because we have a policy, we have an intervention, and we want to find out whether that actually has an effect. right? So one interesting application, right, is paying for sponsored search, right, or somehow appearing at the top of the feed. All right, you can interpret it this way. This is called sponsored search marketing. You see it every day. If you Google anything, the first few enters, they have this little tag sponsored, right? If you go on Amazon, you'll have results that are tag sponsored. This means that these vendors, they actually paid to appear higher in the search, right? And does that actually help the company, right? That's a valid question. So we cannot just do a simple before-after analysis of revenue because the revenue might change for many different reasons, right? So these are called confounding factors, and we cannot easily do randomized control trials, right, in economic applications. So at the same time, the company changing this kind of strategy would like to know, what would have happened if they didn't change the strategy, right? And so one solution is to find a similar company that didn't make the change, right? But this is very hard. So what the economists, for example, come up with, right, is something that we learn in the higher end course, DSE 4231, that's Topics in Data Science and Digital Economy. This is the idea of the so-called synthetic control, right? And the key idea is that we use a combination of comparison units, right? For example, this could be divisions or sub-markets within the same company, right, that did not make the change. And we match it to the data from the unit or market that did make the change before the change, right? And then we can continue observing how the synthesized market or division, right, performs after the change, right? And that provides the counterfactual for what would happen if the company actually didn't switch the strategy, right? So this was used in kind of macroeconomics to study what would happen to Germany, if it hadn't reunited, what would happen to its GDP, what would happen to the Basque Country in Spain, right, if there were no terrorism going on there, right? So in our case, right, we're talking about digital economy. So there was a big study done in eBay, right, which was also kind of academically directed and covered in the literature, right? And the idea was that eBay used to pay for this search marketing, right? And then these economists, they convinced the management to switch off this strategy for some of the designated market areas, right? So you can think of them as like eBay operating in different states of the US, right? And they use this synthetic control method, right, to recover what would happen in those designated market areas if the search still stayed on, right? And this provides what the empirical economists call the counterfactual, the representation of the unit, of the policy unit, right, if it has not been affected by the treatment, right? And what they found is that there was virtually no effect, right? Which is not surprising because eBay is such a big company that it just shows up at the top of the search or close to the top of the search anyway, right? Because there's a lot of traffic going to eBay, and Google usually ranks the searches by traffic, right? So they found out they were basically wasting money, right? You can see on the graph, right? The dotted line is the time where they switch off. The black line is what happened to the actual revenue, and the yellow line is what would have happened, right, if this paid search was still on. And the differences were like on the order of 2% difference, and that was not statistically significant, right? Another insight, right, and another way economics study is changing is that we have different types of data now, right? The kind of new insight of the era is that it's not just the numbers of the data, is nearly everything is data, right? For example, text, right, one of the oldest store of information can be fruitfully analyzed, right, in economic context. Images constitute another important source of data. So we have now satellite coverage of pretty much everywhere, right? We have YouTube videos of speeches by, the Federal Reserve, the monetary authorities, the policymakers, right? So all of this actually can be analyzed, converted into data, and inputted into models. And at the NUS, in the Department of Economics, we have one of the leading researchers in this area, Professor Ruben Durante, right? And this is just an example of one of his recent studies where they use not just text or images in isolation, but two sources together to study sort of presence of gender and ethnic stereotypes in news content, right? So both looking at like newspaper, journals, as well as TV, maybe owned by the same media, right? So this combination of both textual data and image data, right, provides for richer analysis, right? But the data science project in economics is not just about modeling, right? Building a predictive model is only a small part of the project, right? You also need to be able to extract the data. Sometimes that's not so easy, right? You need to manipulate the data, clean the data. Then the typical end user is actually not a professional economist, right? Your boss will not be a PhD in economics, or it will not be a PhD in statistics, right? So you would need to provide the end users a way to interact with your model, and that means a user interface, right? You also need to what's called deploy or ship your application, right? This user interface with the model running inside. And that requires, familiarity with software engineering tools like Git and containerization platform like Docker, right? And finally, you have to convince people that what you're doing is actually valuable, right? And should be adopted. So that involves a communication with stakeholders, right? And this is something that we practice in the third year course, TEC 301 Practical Data Science for Economists. So you see, these are just some screenshots of interfaces of projects students built, right? This is looking at distance travelable from MRT and LRT stations by bike versus public transport, right? So you can see, for example, here, the students plot out the so-called isochrones, right? This is the areas where within a particular time window, say 15 to 20 minutes, how far would you get using public transport versus bike, right? So this kind of can help agencies such as LTA understand, for example, where interventions would be needed and what the cost benefits of these interventions would be. Right, this is another project that looks at nowcasting of GDP growth in the US, right? So nowcasting means that although we don't know what is the GDP right now, right, in Q1, because the data has not been reported yet, we can actually leverage on more high frequency data, such as monthly data on economic indicators, to provide an estimate of what the first quarter GDP actually is, right? And as you see, there are different models that students employ here. They display, different forecasts, so then the user can, for example, get a sense, what is the spread of different estimates and adjust their decisions accordingly, right? This is something also relevant in today's world, right? Another project looked at geopolitical distance between Singapore and the other countries in the world, right? And so they come up with a metric, right? How do we measure that quantitatively? They provide an interface where you can see this stuff on the map, right? And you can apply different filters and zoom in into things like, bilateral trade and other indicators, right? To sum up, economists these days require, domain knowledge in economics, of course, but increasingly these data science skills, which are now called very frequently AI skills, right? A lot of stuff that's called AI skills these days has little to do with actual AI, right? And it's more like a rebranding of machine learning and other sort of analysis of data, right? For years, right, econometricians have been saying that economics without econometrics is just coffee talk, right? Just people exchanging ideas. And now we can sort of say that using data science in the sentence, right? The interaction between economics and data science is getting much more pronounced, both in academic research and in the industry. So whether you're targeting grad school or whether you're targeting, industry, this is unavoidable, right? You will have to learn the skills one way or another. Generative AI these days is only accelerating this trend, right? It just makes these things progress faster, right? And so knowing how to code, right, is not enough, right? You must be able to use the economic reasoning to identify the problem and choose appropriate strategy for solving it, right? And getting quantitative answers from the data. Actually, coding now becomes easier because these AI tools that help you to actually code the thing, evolving very fast. The bottleneck is people do not know what exactly to code, right? What is the question? And to evaluate whether the answer is good, right? That is really, I think these days the value of university education, and that is, what you will be getting from this program, right? If you choose to enroll. So as Chun Chun already showed you, right, these are the placements from our first cohort. So the roles, somebody asked about the roles. The roles, they vary a lot, right? But predictably, they are things like, data scientist, data engineer, data executive, researcher, research associate, AI apprentice. A lot of those things, they have different names, but you kind of get a sense that they all involve some sort of data-driven component behind them, right? And obviously, these roles is to assist in, value creation at the companies or policy evaluation at places like Ministry of Manpower, Monetary Authority of Singapore, right? Interestingly, right, I would highlight there is two students who are actually SPH scholars, right? And they are now working at Business Times and somewhere in the SPH media as project analyst, right? Even journalism, right, has become very data intensive. And to kind of write meaningful pieces on the economy nowadays is not just enough to be good at English, right? And not just enough to understand economics, but you also need to be able to sort of back up your analysis with some figures, some modeling, you have to visualize your data. And we actually have visiting lecturers from SPH come to our practical data science course to give a guest lecture about, what is the state of data visualization and media today, right? And how we can sort of tell more striking stories with data. Because as I said, impressing stakeholders, right, convincing them of the value of what you do, of your work, is actually could be much more important than the work itself. Right, so that's all from me, and we're happy to take any questions. Okay, so maybe I will go through Q&A and my colleagues can chime in if I get stuck. So the first question is, what kind of student profile are we looking for? We're looking for smart students. That's the simple answer, right? In terms of, what on paper, right, I think we are looking just for very good result in H2 math, right? And in general, students who are quantitatively able, right? So that's kind of the profile. So students who are not afraid to engage with the quantitative analysis, but also, of course, open-minded and students who like to think about stuff, right? But in terms of like documents, right, that's a very good profile for A levels, right? Specifically with H2 math. How different are the modules where you integrate data science and economics and then blah, blah, blah. Okay, so what's the difference? The difference is that the domain, right? I mean, DSA program, right? It does not have a specific domain attached to it, right? So you just study the tools And then if you look at the, for example, topics from DSA 3101, they're all over the place, right? You could be working on, sorting electronic waste in NUS using data captured from the cameras, right? I mean, this is fascinating, right? But this is not economics, right? And maybe a lot of people can do it without background economic knowledge, right? Or, they analyze things like football matches and weather predictions and traffic in the library and things like that, right? So a lot of these problems, they require handling of data and building applications and whatnot, but they do not require economic knowledge. You ask the students to do something in economics, they fail miserably, right? Because economic data is special. Economic data is very different. And without knowing how to work with economic data, person will have tremendous difficulties producing anything meaningful, right? So to give you an example, a lot of economic data is time series data, right? The data that evolves over time rather than a snapshot in time, right? The traditional data science deals a lot with this kind of snapshot in time, right? So for example, we have 1,000 customers captured at this particular moment, and we want to find out some pattern from it, right? Country's GDP, right, it evolves over time. A country that was growing fast last year, right, is not going to suddenly shrink next year, right? So there is some path dependence, and there are statistical tools, right, that one needs to learn, for example, to deal with this path dependence, right? Also, things like understanding why people act, how they are, that, they are economic agents, they're optimizing some sort of criterion, right? This also helps in designing certain experiments and certain policies, right, that would not even occur to a kind of standard, let's call it data scientist, right? So what we do in these courses, right, is we focus on economic applications and financial applications, right, where the integration comes from the fact that, okay, here is the background knowledge you need to have to actually meaningfully say something about this data, right? And also some statistical methods are more suitable for economic data than others, right? For example, everybody these days is enamored with deep learning, but deep learning is actually largely unnecessary and even kind of counterproductive in many economic applications, right? So if a computer scientist will throw deep learning at the problem off the bat, right? We teach kind of a strategy that, progressively grows the model, and then, maybe you will build something like a random forest, right? Which is much simpler than a deep learning model, much cheaper in all senses than a deep learning model, but will still produce similar or even better performance, right? So that's kind of the angle. That's the value of integration. If you're taking a double major, for example, in data science separately and economics separately, you would have to do all this legwork of connecting the two by yourself. And let me tell you, this is not a simple task, right? Especially for somebody who is not like a PhD in either discipline. Yeah. So that's the main value from integration. What is the data science starting salary and how it compares to other jobs? Fair question. I did not ask them what is their starting salary, right? And I don't think there is a separate figure in the graduate employment survey available, but I think it's closely correlated with the DSA starting salaries, which are publicly available on the NUS on the graduate employment survey, right? So you can kind of guess by the roles that I mentioned, right? So such as data engineer, research analyst, management associate at the bank, right? DBS or CBC, those are the typical jobs. So I don't know what is now 5,000 roughly as an average salary, maybe. But again, that's case by case, right? Depends a lot on organization and the particular role and the particular sort of qualities of the student, right? What kind of internships students take? Our students take a lot of internships, that's one. And from the original batch, right, the experience was that a lot of the students who took an internship, they were invited back actually, right, to continue. So a lot of the placements, they actually grew out of internships. What kind of internships? All kinds of internships, right? So a lot of our students interned at MIS. Also, they intern at places like, all the major banks, DBS, OCBC, UOB, Standard Chartered, Goldman. They also intern at more niche things like fintech startups, right? And analytical firms and private hedge funds. So, it depends, I guess, on circumstances, right? What kind of internship you eventually acquire. But our students were very successful in securing internships. Almost all of them have done multiple ones, right? So at least 2 or 3. And then we also have this UPIP program, right? So that's where you can take an internship for credit, right? So it's a full-time internship that can be either self-sourced or it can be, chosen. We have a portal where employers post their internships. So a lot of our students also go for that experience. Yeah, many of those, they actually grow into like a full-time employment later. Is there an interview selection process? There are different types of interviews, right? So there are interview for scholarships, and there are interviews for something that's called aptitude-based admissions, right? But not everybody obviously gets interviewed, so you may or may not be asked to do an interview. That's the simple answer. How does DSE compare to business analytics or CES for getting data analysis science jobs? As I said, CES, right, is a person who can write software but does not have a domain knowledge, right? So, of course, DSE students cannot compete with CS students for positions such as a software developer, right, or software engineer, right? No question about that. That's what CS is supposed to do, right? You build software. I don't think CS students would be very successful for certain, data analysis jobs, right? Because unless they have a double major or something like that, right, it would be very hard for them to meaningfully analyze data from a domain they have no idea about. So DSE is more about, there's a range of sort of entries, right, into this whole quantitative spectrum, right? CS is kind of at the very fundamental level where, I am the one who writes the software that you use to analyze the data, right? And DSE would be somewhere, a bit higher, right, where we're not worried too much about writing the software itself, right? Of course, we do have the skills, for example, to build an app, right, that would connect the user with the model that we designed, right? But we are more about using, say, available Python libraries, R libraries, right, for actually asking the correct questions. That is something that a CS person will have great difficulty with. What is even the question to ask, right? What is even the policy to investigate? And secondly, devising a proper strategy given the data, because the strategy will always depend on the structure of the data, right? Devising the strategy, executing it, interpreting results, packaging them all, and communicating them, that is where we come in, right? So, yeah, very different majors. Business analytics, it's run by computer science, right? So although they claim, yes, we do business analytics, it's still very CS heavy, right? So I don't think that they learn enough economics to actually be competitive with DSE or econ students on that front. What role DSE graduates do? Trading, analyst, global market research, all of that and more, right? So roles like country risk analyst, we have one who is doing that at Fitch, junior trader at Theme International Trading, data scientist at Micron, software engineering analyst at Goldman. We have ML engineer at MasterCard, big data engineer at ByteDance, right? Analytics engineer at Razer, that's the gaming company. We have a journalist at Business Times, executive in data analytics at Ministry of Sustainability and Environment, management associates at DBS, OCBC. Right, so these are the range of jobs that the graduates got. We also have 2 very successful graduate school placement, right? So First of all students who applied for master got very good offers. Not all of them chose to take them because they got good jobs, but the ones who took, one is an LSE with a master in private equity, and the other one is an MIT doing a master in finance. What are the differences between DSE and pure economics? The difference is that in pure economics, you focus more on kind of fundamental economics training, right? And you do not do all this kind of data science core, right? So you don't do things like, data structures and algorithms. You don't do the integrated courses, right? And you don't do the kind of the DSA prep. So in economics, you still do have quantitative subjects, right? But you are not as sort of geared towards this role of being able not just to do the analysis itself, but to also build some, environment around it, right? And make it sort of user-friendly. Is the demand for DSE graduates high in SG? I don't know. I'm not the recruiter, right? But just looking at the data on placements, which is arguably limited, right? We only have one cohort, but students did not have trouble, finding jobs, right? So pretty much all of them who made a good effort gainfully employed. My opinion is that the demand for such graduates would be steady, right? Because what's happening these days, right, is a sort of a democratization of coding, right? But as I said, coding in itself doesn't help you solve problems, right? So now the demand will be for people who can ask the right questions, right? And who can audit the answers, right? Because even if the AI does everything, at the end of the day, you must be able to evaluate whether what the AI has done actually makes sense, right? And that's kind of the difficult part that the computer scientist cannot do, right? Because if the computer scientist does not know economics, then how can he, for example, evaluate whether the analysis done on a policy is actually methodologically sound or not, right? So AI makes things faster, right? Which means that it also makes mistakes faster. So the need for the fundamental understanding of what is going on, right, is not going away, at least not yet. What's the difference between DSE and business economics offered by the business admin faculty? I'm not super familiar with business economics program, right? But I would wager a guess that it is much less quantitative, right? So it's more about things like arguing cases, presenting cases, but you would not have the skills to actually build stuff. Concern is that DSE will be half economics and half DSA, so it will not be fully learning one area and may lose out to pure economics, a pure DSA major. As I said, right, lose out in what, right? So you would not lose out to the pure DSA major in the role that requires economics for sure, right? Because by construction, the pure DSA major does not have any background in economics, right? Whether you would lose out to the pure economics major, I mean, that depends on the role, right? If the role requires some particular subfield of economics where you may not have time to take electives, maybe. But at the same time, if you're targeting this kind of quantitative roles, right, the tech companies and whatnot, right, even the ministries, I think if you play your cards right, if you take economics electives, right, instead of introduction to Korean, as your unrestricted electives, you would be very competitive, right? Because, for pure economics majors, they have much, much fewer formally kind of quantitative courses that support this kind of, machine learning enabled economic analysis. Okay. Economic jobs with data science background or data science jobs with economics background. I'm not sure I see the difference, but I would say economics jobs with data science background, right? So at the forefront, you would need to be able to, think what is the problem and analyze the problem, suggest solutions for the problem, right? And then the data science skill will enable you to execute that, right? Rather than, you're a software developer or something like that. Yeah, that's the focus. Anybody can answer this 90 RP versus 70 RP system?
Maybe let me chip in here. So yes, indeed, from this coming emission exercise onwards, we will be using, we will just count the H2 and exclude the H1 score. So if you are going to apply for DSE program for this year, or in other words, whether you are NS man or maybe a female student, if you are applying for admission this year, we will just use the 70 RP system. So that you will not, so for, in other words, for those NS men, you will not be assessed differently.
I think there is also a question in the chat. What is the future AI impact on this program? Well, I don't know, right? Because nobody knows the future. But I think I would be more excited rather than pessimistic, because this is actually the area, right, where AI can make kind of annoying things easier to do and make exciting things kind of more the focus of your work, right? So I think definitely it will be, as economists say, a positive productivity shock, right? And it will enable us to do basically things that took us longer time and shorter time and things like that. As I said, AI does not exempt you from understanding math, from understanding statistics, from understanding economics, right? Because even though AI can produce things seemingly on its own, right? At the end of the day, as adults, right, you are responsible for every single line of code and every recommendation you write down. So without the grounding in the domain area, right, you're not going to go far. I mean, you can only fake it this far without any background. So, but I think, yeah, it's going to be one area, and it's happening already, like at the academic level, right? So people doing new workflows for research and stuff like that, and we will be integrating that, of course, into the way we teach in this program, right? But this notion that some of the so-called tech bros, throw out there that AI will like eliminate the need for college education, I think they got it wrong, right? Because somebody still needs to vet the AI, right? At least for the next, I don't know, number of years, right? It does not seem to be good enough, right, to completely replace somebody with an actual expertise in the field. So is DSE quantitative or pure economics is more qualitative? I would say pure economics is not that much more qualitative, but the focus is a little bit different, right? So DSE is more quantitative in the sense that you get more technical tools like pure math, statistics, and let's call it programming, right? But essentially working with various computing environments, right? Such as, learning, developing tools and doing sort of end-to-end full pipeline projects, right? Whereas economics is still quantitative, right? But it's quantitative in a bit of a different way, right? So it's more kind of based on, formalizing certain mechanisms in the economy, right, via equilibrium models. It's developing frameworks basically for understanding why people do what they do and why what happens to countries, which still involves math, right? Still involves calculus. It still involves things like optimization, right? Optimal control and all this stuff. But it may be a little bit less geared towards the final user, right? So it would be, you could say it's quantitative in a more kind of academic focus kind of way. So as a student, right, you kind of have the option and the luxury, right, to kind of customize your profile, right? So as you go on through the programs, either economics or DSE, you would think, what do I want to be, right? Where do I want to fit in? And then you would take courses that would sort of build your portfolio of skills geared toward that role, right? I mean, there is no economist who knows everything about every field of economics, right? I mean, people specialize. They specialize in one or two subfields, right? And that's it. And those two subfields would be a good fit for a particular range of jobs, right? But not the other range of jobs. So even within economics major, right, you could have different profiles. As you would see, right, there's different specializations, right? There are people who are more geared toward macro policy and people who are more geared towards, for example, NGOs and some kind of social oriented ministries and institutions, right? And so, yeah, it's all quantitative, but in a different kind of way. I would say DSC is more data intensive, right? And more sort of puts you into more realistic scenarios that could actually happen in the workplace. The question is why there's no asset which auto-manages everything from coins to stocks to bonds to currencies. And the answer is if there was, then mutual funds would not exist, right? Because that's a simple economics. If something can be done for free, then the paid service would disappear, right? As to why, enroll and you'll find out. This is not something that can be answered in 2 minutes. But if you know basic economics, right, you would know that if people manage something and get paid for it, right, then there is premium in that. How to decide on DSC versus pure econ now? So I think one factor would be how good or how averse you are to doing stuff on the computer, right? So if you don't like programming, coding, this kind of stuff, then econ might be, but still interested, in economic policy and finance and stuff like that, then pure econ may be better for you. If you really like getting your hands dirty with data and, building graphs and stuff like that, you want to get into the space of companies that, work with consumers, like e-platforms like Shopee, Lazada, Amazon, right? Then DAC might be a better choice. What roles do DAC graduates have in investment companies? Can it be at the frontline role? Well, anybody I think can be at the frontline role in an investment company, right? It's the back end that's more technical and more difficult to get in. But to answer your question, at Fitch, our graduate is a country risk analyst. At Goldman, it's a software engineering analyst, right? So basically at the back end. At DBS or CBC, we have management associates as well as a data scientist, right? At where else is finance? MasterCard, we have machine learning engineer, right? Theme International Training, junior trader. So, I mean, these front roles, they depend more on your soft skills, right? Charisma. I've even seen English majors, right, take those roles. But yeah, DSC prepares you for both, you could say, right? Because front end is mainly communication, right? The back end is mainly technicality. Will DSE be coding heavy? Yes. So that could be one, deciding factor. DSE versus pure econ is DSE is definitely much more coding heavy than econ, right? I mean, DSE, you start off, there's a CS 101 introduction to programming that's already kind of, exposing you to proper programming techniques, right? Then there would be like data structures and algorithms. That's a CS class as well. And then all the integrated courses, right, would require you, again, from year one to jump into things like R and Python, right, off the bat. Whereas for econ, you start, strictly speaking, coding, right, around year 3, 4. So if you are averse to coding and messing around with data on computers, you may be a better fit for econ. If you love that stuff, then the DSE would be a better fit. Note that, however, right, talking about options, if you start out as a DSC, it is more or less easy to switch to econ, but not the other way. Right, so it's very, very difficult, almost impossible to switch from another major into the DSC program, because DSC program is a separate, so it's a direct admission major, right? It's not like, oh, you admit to CHS and then select it as one of the majors. It's a direct admission program, so it's a more selective, right? So if you get admitted to DSC, right, you later have an option to switch majors, right? And that's relatively easy. Whereas if you get admitted into pure econ, you will not be able to upgrade to DSC. So that's something to consider. And then, of course, ETFs are not limited to stocks, right? There is another running question. ETFs, they're built around a theme, right? And essentially, if you do your research, you'll find that there is many, many flavors. There are crypto ETFs and gold ETFs and all sorts of combinations. Again, this is economics in action, right? If there is a demand for a particular product, right, then the market will provide it. What kind of master degree of the DSC will be recommended? I don't know, whatever you want, right? But what I can say is that you will be in a very good position to go to a master in the best places worldwide, right? As I said, from our current graduates, right? One is in LSE doing a master in private equity. The other one is in MIT doing master in finance. Another one who is now working at ByteDance, she actually applied for grad school and got an offer from Columbia University for master in financial engineering, but she decided that she just prefers the job. The job offer was apparently very good. So she didn't take up Columbia and she went to work at ByteDance. I cannot recommend master degrees, right? Because that depends on your preferences, right? Master degree is usually a gateway in a particular, industry or a role, right? So for example, if you want to become like a quant, you may consider a master in quantitative finance or master in financial engineering, right? And then, yes, DSC will give you a good background to be successful in your application, right? Or if you want to, for example, do a PhD in economics and you would like a master beforehand, you may apply for a master in economics. And again, yes, DSC will give you a good background, to be a strong applicant. So I would say that for a master's in finance, economics, some sort of analytics or data science, DSC will give you a very, very solid background. Yeah, it would make you a very strong applicant. MBA, right? Just to there's an MBA. MBA is typically done after some work experience, right? So it's very rare to do an MBA after just undergrad, right? Because the value of MBA is more like networking. Isn't finance more BBA than DSE? Well, finance has different flavors, right? I mean, there's quantitative finance in math, which is very different animal from finance in business school, right? And then there is, business analytics, whatever, which is more like a CS flavored. So in DSE, right, you would learn techniques that work with economic data, but also financial data is quite similar, right? So it's a lot of time series data, a lot of particular stuff. So in that sense, right, you would also be prepared to, and a lot of the tools, right, like predictive modeling, they are common between economics and finance. So in that sense, you would be well positioned to work in the financial sector as well. Okay, any more questions?
If there is no more questions, then thank you very much for joining us today. We have another physical open house on the Saturday of the following week. So we look forward to seeing all of you again during the physical session. Okay, then thank you all again and wish you a nice day. Then let's end it here.